Good morning, class. Welcome to grade 10 mathematics. Okay, our first chapter in Math 10 is all about sequences. We have four kinds of sequences. What are they? We have the arithmetic sequence. Next is the geometric sequence, harmonic sequence, and the Fibonacci sequence. Okay, before we take up those sequences, and before we take up the first sequence this morning, okay, we are going to recall first what is a sequence. Okay, so class, what is a sequence?
Okay, a sequence is a function whose domain is a finite set 1, 2, 3 up to n or an infinite set 1, 2, 3 and so on. So if you will observe, when you say finite set, there is a limit. And when you say infinite set, there is no limit. Okay? So class, because a sequence is a function, therefore we have two variables involved here. Okay? Same with your lesson last time from grade 8, you have table of values x and y. But this time, we are going to have table of values in the form of n for your first set of numbers and a sub n for your second set of numbers. So here we have 1, 2, 3, 4, and 5 for n. And for our a sub n, we have 3, negative 1, 1.5, 10, and pi. Okay, so what is the partner of 2? Negative 1. And what is the partner of 5? We have pi. So we can also write this in ordered pair like 4, 10, 1, 3, and so on. Okay, so here, if the number is only until 5, then it is a finite set because there is a limit. Okay, did you get it? Is it clear? Okay, now let's proceed to the next. Okay, here is another example. Okay, we have another table of values again. We have n, 1, 2, 3, 4, and 5. And we have a sub n, 4, 7, 10, 13, 16. So what is the partner of 3? We have 10. Okay, so class, if we will continue this table, what do you think will be the partner of 6? Okay, it must be 19. How about 7? It must be 22. How about 8? We have 25. So, we can continue. Okay, so if there is no limit, this is an example now of an infinite sequence. Okay, since we can find the second set of numbers, okay, if we have the first number. Okay, now we have a general rule for this, and our general rule, same with our lesson from grade 8, the general rule for this is a sub n, or the second number, is equal to 3 times n, or 3 times the first number, plus 1. So we have a sub n equals 3n plus 1. Okay, you may recall that for your grade 8, or from your grade 8 mathematics. Okay. Okay, let's consider the same sequence again, wherein we have our n from 1 to 5 and our a sub n from 4 to 16. Okay. This time, class, we are going to use another form in writing a sequence. And this is the form we are going to use in our grade 10 mathematics. Okay. The sequence will be written in this way. 4 for the first number, 7 for the second, 10 for the third, 13 for the fourth, and 16, and so on. Okay? So class, if you will observe in the sequence, we have members, and each member of the sequence is called, okay, term. So what is a term? A term is the member of the sequence. Okay. So we have the first term, which is equal to 4, or a sub 1. We have a sub 2, which is equal to 7. The third term, or a sub 3, equals 10. Fourth term is 13. The fifth term, or a sub 5, equals 16. How about if you will be asked, what is 20th term? Okay, are you excited to learn more on that? We are going to take up that on our next topic.
An arithmetic sequence. Okay, so this is the first kind of sequence that we are going to take up. What is an arithmetic sequence? An arithmetic sequence is a sequence, okay, where every term after the first is obtained by adding a common difference. Okay, this common difference is denoted as small letter d. Okay, we're going to emphasize that later. Okay, so let's have examples. In the sequence 4, 7, 10, 13, 16, and so on, okay, if you will observe, there is a number added, same number added, and that same number is the constant. Okay, what is the constant number added to each term? Okay, what is your guess? That is equal to 3. Very good. Okay, next one. And that common number or same number is what we call the common difference. And this is the letter D or lowercase d. So what is the common difference? The common difference is the constant number, which is the difference between two consecutive terms of an arithmetic sequence. Okay, so let's have another example in 15, 11, 7, 3, and so on. Okay, if you observe, our numbers are getting smaller. Okay, then we can say that our difference is a negative number, and that is negative 4. Okay, got it? Okay, very good. Now let's proceed to more examples. Okay, we have the sequence 3, 5, 7, 9, and so on. Our D equals 2. Okay, how about 10, 5, 0, negative 5, negative 10? What is our D? Okay, D equals negative 5. Next one, negative 2, negative 5, negative 8, negative 11, negative 14. What is our D? Our D is negative 3. Okay, that is the number added. Okay, next one, 9, 13, 17, 21, 25. We are adding what number? Our D is equal to 4. Okay, and for the last example, we have 81, 64, 47, 30, 13, and so on. Since our terms are getting smaller, our D must be a negative number, and that is negative 17. Okay, very good. Okay, let's head now to our next subtopic. If you will ask earlier class, okay, in our topic, okay, I asked you to find a sub 20 on our term. So here we are going to solve that. How to find the nth term of the arithmetic sequence? The nth term, okay, you can find 100 term like that. Okay, let's have some first example, and that is the same problem we had earlier. What is the a sub 20? So find the 20th term of the sequence 4, 7, 10, 13, 16, and so on. How are we going to answer that problem? We can use adding by adding 3. Okay, like 4 plus 3 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 and so on until you have the 20 number. Okay, or the 20th term, and you are going to take that as your answer. But how about if you were asked the 100 term? So therefore you need to use the formula. There must be a formula for that. Okay, and that is what we are going to take up today. Okay, so we have the solution. First, look for your given. Okay, what are the given? Okay, you have your a sub n. You are looking for the a sub n or the last term. Our first term is 4, and our n is 20. Our d is 3. So the formula that we have is a sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub n here is our last term, the 20th term here, the first term, and this is the n. Okay, so let's apply algebraic manipulation to solve the problem. Okay, we have a sub 20 since our n is 20. So first term is 4, Next is the quantity 20 minus 1 times 3. Got it? Okay, let's move on to the next. A sub 20 is what we are looking for. So just subtract 20 and 1, we'll get 19. Then we can solve backward. Add 3 times 19, that is 57 plus 4. So that is our A sub 20. 4 plus 57. Okay? And then, of course, 4 plus 57, our answer is equal to 20th term is 61. Okay? So that is our 20th term. Okay? Got it? Let's proceed on to the second and last example. Okay? So example 2, we have this problem. How many terms are there in an arithmetic sequence whose first term is negative 3? Common difference is 2 and the last term is 23. Okay? First solution, write the given. Okay? We have a sub n or the last term 23, then difference is 2. Okay? And first term is negative 3. Here, we are looking for the n or the number of terms. How many terms are there? Okay. Now, let's have the formula. A sub n or the last term equals first term plus the quantity n minus 1 times d. Okay. By substitution, we have 23 for our last term, negative 3 for our first term, then plus the quantity n. We don't have n here, and our d equals 2. Okay? N minus 1 times 2. Next, we are going to apply distributive property here to remove the parenthesis symbol. So we have n times 2, and the negative 1 times 2, we can have now 2n minus 2. Add that to negative 3. On the left side, you have your 23. And then solve further. By transposition, we have 23 plus 3, then plus 2 equals 2n. Then add them together. 23 plus 3 plus 2, you will have 28 equals 2n. Then divide both sides by 2 to get an answer which is equal to 14. Therefore, there are how many terms in that sequence? We have 14 terms in that sequence. Very good.